Mars is the red planet that we see from orbit, but just underneath a thin layer of dust, we see a whole rich array of sulfate-rich minerals that many scientists believe may have been formed hydrothermally. And we see those very similar minerals in the rocks and the hills surrounding us here at Lassen.
In 2006, NASA's Mars Reconnaissance Orbiter probe arrived at the red planet. It's equipped with the Compact Reconnaissance Imaging Spectrometer for Mars, better known as CRISM, which plans to revolutionize our view of the planet. Using visible and infrared light, the instrument has been scanning for evidence of ancient liquid water in Valles Marineris, a massive canyon system ripped into the surface by the volcano Olympus Mons. The area may hold hydrothermal deposits.
Mars is unlikely to be active at the moment, but in its active phase, it may have been that hydrothermal waters were driven by the massive volcanoes that we see on Mars today, and Mars may have been able to form active hydrothermal systems such as this and build up a rich layer of sulfate minerals on the surface of Mars.
Early Mars was much more habitable than the current day Mars. The planet cooled off. It's now too cold and too dry to support life. So if there was early life on Mars, it's probably not on the surface anymore, and it could potentially have migrated into the subsurface, into habitable environments below the ground.
Research scientist Jennifer Heldman is also on a quest to find life on Mars by understanding how microscopic organisms survive in extreme environments on Earth. But instead of investigating the hot spots on our planet, she scours for life in cold places.
Right now, specifically at Lassen Volcanic Park, we are looking at snowpack deposits. And we're especially interested in these snowpacks because they have snow algae living in them. So in the late spring, summer months, you'll see the snowpacks colored bright red, streaks and ribbons of red running through the snowpack, and that's the algae, so there's actually life living in these snowpacks. And so we're studying the physical conditions that the snow algae like to live in and applying that to snowpacks on Mars to see if the same conditions within snowpacks on Mars might exist.
NASA's Mars Global Surveyor has recently discovered Martian gullies that could be the ancient remains of snowpacks.
We're looking at these to study this phenomenon. Can those snowpacks actually melt, generate liquid water, and also potentially provide habitable environments for life?
To better understand snowpacks on Mars, Heldman conducts experiments in Lassen Volcanic Park.
So this is our setup for measuring temperature and light profiles through the snowpack, and what we're doing is using this instrumentation to understand the physical conditions within a snowpack that are able to support snow algae. This winter, this will get completely covered in snow and buried, and so we have sensors mounted on a pole here. So we have some moisture sensors here, and then these little ones are just temperature sensors. And then at the very top of the pole we have a light sensor which measures incoming solar radiation, and then down here covered in the bucket we have a tipping rain gauge, and this will measure the amount of liquid water that flows down through this bucket. The snow algae that we're seeing here thrives in these very low condition environments. It's very happy being at 0 degrees C. It's very happy in low light conditions. It's very happy in the nutrient poor conditions of a snowpack. Once we understand the conditions that support life here in the snowpack at Lassen, then we're also doing studies of snowpacks on Mars. And if we find the same conditions on Mars, you have to ask yourself the question, well, if these snowpacks on Earth are habitable, could those snowpacks on Mars also be habitable?
In addition to Martian gullies, two massive polar regions may also be places where life still exists on Mars. On August 4, 2007, NASA launched the Phoenix Mars Lander spacecraft. When it finally arrives on the red planet in early June, it will probe its icy poles. Aboard the craft, robotic arms and dig trenches will plow through the layers of water ice to see if there are organic compounds, the building blocks of life.
We might go to the polar regions of Mars, drill down into the ancient ice, bring up organisms that are dead. They've been shelled by radiation, but we might be able to, by studying their biochemistry, patch them back up and resurrect them.
But even if Mars holds liquid water, could it have ever sustained larger animal life? When searching for Earth-like life in our solar system, scientists look for the presence of liquid water and carbon. They're crucial ingredients for life on Earth. But are there other indicators? Some scientists believe plate tectonics is necessary to promote biodiversity and act as a defense against mass extinctions. On Earth, plate shifting created continents. Without land masses, Earth would have remained a water world, and therefore many species, including humans, may not have evolved. So why does plate tectonics exist on Earth and not on other terrestrial planets, such as Mars?
Because Mars is smaller than Earth, likely its interior cooled off faster. And it cooled off before really plate tectonics were able to start on Mars. Fortunately, on Earth, we still have plate tectonics. And plate tectonics is the grand recycling system of our planet, recycling materials in the atmosphere, in the surface, and the subsurface. And Mars never had that.
Plate tectonics also keeps Earth's temperatures moderate by recycling chemicals to keep the volume of carbon dioxide in our atmosphere uniform.
Lacking plate tectonics, it didn't have the persistence of Earth. It developed maybe habitable conditions and maybe complex multicellular life very quickly, and then it dies off because it doesn't have the long-term potential that plate tectonics gives the Earth.
Plate tectonics may be one indicator for Earth-like life. But evidence suggests there may exist another type of life on a moon that belongs to the Lord of the Rings. In 2004, NASA's Cassini mission conducted flybys around the gas giant planet of Saturn. A year later, the spacecraft released its Huygens probe into the atmosphere of Saturn's largest moon, Titan. The images revealed that Titan has similar features to Earth, such as weather cycles and volcanism.
Saturn's moon, Titan, is a very complex place with rainfall, rivers, and seasons, and meteorology, and a complex atmosphere, and interesting chemistry. Again, it's not going to be our kind of life, but there are flows of energy and organic compounds, and some other kind of life could flourish.
Radar imaging data has revealed the presence of liquid lakes on Titan. Although they're comprised of ethane and methane, they may be reminiscent of what water on Earth was like 4 billion years ago.
Titan, the moon of Saturn, is a really cool place, literally and figuratively. It's so cold that there's no liquid water. The ice there would